Welcome to a lesson on describing a function rule and writing a function rule from a description. We want to complete the following table where we're given the symbolic rule or the function rule as a formula, and then we're asked to describe the function in words. So our first function is h of x equals x minus 5. So the input is x and the output is h of x. So h of x subtracts 5 from x. So let's state the function rule as h of x subtracts 5 from the input. Next we have k of x equals 5 minus x. So the function k of x subtracts x from 5, but again, because x is the input, let's describe this as the function k of x subtracts the input from 5. So notice how h of x and k of x are different function rules. Here we're subtracting 5 from the input x, and here we're subtracting the input x from 5. Our next function is r of a equals the absolute value of a. And again, because a is the input, let's describe r of a as the function r of a takes the absolute value of the input. Next we have s of t equals negative t, or the opposite of t. So here, because t is the input, we can describe s of t as the function s of t takes the opposite of the input. It would also be okay to say s of t takes the negative of the input. Now for the remainder of the table, we're given the written description of the function rule, and we're asked to write the symbolic rule or formula for the function. So here we're told the function f of x divides the input by 5. So because the function is f of x, we know the input variable is x. So f of x divides x by 5, which should be in fraction form x over 5, where a fraction bar means division. The function rule would be written more commonly in this form here, but it would also be okay to write just f of x equals x divided by 5. But the fraction form would be much more common. Next, we're told the function g of x adds 7 to the input. So because our function is g of x, we know the input is x. And the rule is we want to add 7 to the input, which means we want to add 7 to x, which is x plus 7. So our function is g of x equals x plus 7. Whatever the input is, we would add 7 to it to get the output. Function c of t squares the input. So if the function is c of t, now the input is t, and the function c of t squares the input. So our formula is going to be c of t equals t to the second, or t squared, or we can say the square of t. Next we have the function p of n adds 1 to the input and then doubles the result. So here the function p of n performs two operations, and because the function is p of n, we know the input is n, and the first thing p of n does is adds 1 to the input, or adds 1 to n, which would be n plus 1, then doubles the result, which means we want to take the quantity n plus 1 and multiply by 2. So we could put times 2 here on the right, but because multiplication is commutative, it would be more common to write 2 times the quantity n plus 1. But again, it still would be correct to write p of n equals the quantity n plus 1 and then times 2 if we wanted to. And finally, our last example, the function q of w doubles the input and then adds 1. So because the function is q of w, the input is w, and the first thing q of w does is it doubles the input, which means it multiplies w by 2, which we can also write as 2w, and then it takes this result and then adds 1. So we have the quantity 2w and then plus 1. So notice how the order of the operations do affect how we write the function formula. Here we first add 1, get the result, and then multiply by 2. But here we first double the input, which is given by 2w, and then we add 1 to the result. And notice how these function rules are not equivalent. If we distributed here, we'd have 2n plus 2, and here we have 2w plus 1. I hope you found this helpful.